Hello, and welcome to this week's live session here on YouTube from Impact Subsea. I'm Ben Grant, Managing Director, and this week I'll be answering your questions on any of our sensors or software. This week we're going to focus on looking at our range of underwater altimeters, which is the ISA 500 range. Now, one of the questions we often get asked by people first approaching us to learn more about the ISA 500 altimeter is which altimeter is right for me. So in the ISA 500 range, we have around about 11 different configurations of altimeter. So this ranges different housing materials, different housing configurations, and some without housings at all. And so what I'll do initially is just talk you through some of the options that are available. So one of the altimeters, this is the ISA 500 in titanium, and we refer to this as the forward-looking housing, as the transducer looks straight out the end of it. This was the first model which we launched back in 2015, and since then we've added additional models to the range. So the ISA 500 in titanium forward-looking has the capability to measure up to 120 meters away from the seabed. Depending on the seabed type, you may actually get a longer range than this. We've had up to 175 meters when you have a rocky seabed, which is a really good acoustic reflector. So you get long range measurement capability, and you also get a very high degree of accuracy. The ISA 500 itself actually resolves range to 0.7 millimeters, then rounds it up the nearest millimeter. And there's a little example in the background here running. We've got an ISA 500 in our test tank just here, measuring distance here. So you can see the distance being measured on screen there. It's measuring about 0.628 meters. So you can see the last digit there, that's the millimeter value. And you can see it's very stable and very accurate. And if the altimeter is moved just slightly, you'll see that value change the altimeter up and then back down towards the base of our tank. So the ISA 500 provides long range capability and very high degree of accuracy as well. Also optionally integrated into the altimeter is heading, pitch and roll. And so you can see that being fed out here. We're heading to magnetic north and pitch and roll as well. So to magnetic north, it's accurate to plus or minus half a degree, and the pitch and roll is accurate to 0.2 degrees. So that's the ISA 500 in titanium, forward looking. We also do the same sensor, the same capabilities in terms of range and accuracy, in what we call the right angled housing configuration. And essentially, instead of having the transducer point out forward, it points out to the side. This is quite a useful kind of configuration if you want to put the ISA 500 altimeter into a slimline form factor vehicle, such as AUV, or if you want to put it onto a towed tool or towed sensor, such as a magnetometer. It's the right kind of profile to fit within the nose cone and point down to the seabed and give you range. Then we also do the altimeter, the ISA 500, in acetyl plastic in forward-looking configuration and acetyl plastic right-angled configuration. The dimensions and capabilities in terms of range and accuracy are exactly the same as the titanium counterparts. The only thing that changes is the weight. You get a little bit lighter being plastic, and also the depth rating. So the titanium sensors, as standard, depth rate to 6,000 meters. In acetyl plastic, the depth rate 1,000 meters. So still more than sufficient for a lot of kind of shallow water application work. And if you want altimeter solution, potentially for an AUV, where you don't want to have a full housing, maybe you want to integrate the transducer into the body of the AUV and the electronics into your electronics pod. We do also offer the ISA 500 OEM option, which is a single board PCB, which has all the capability on it, and a transducer, which connects on the end, or you can disconnect the two, and you have the transducer separate from the PCB, and simply connect the two with a piece of coaxial cable if you want to have the PCB mounted in a separate location to the transducer. So it's not always convenient to have the PCB immediately behind the transducer. The OEM option is nice and simple. It comes with a terminal block on it, which you can wire straight into, and that comes with all the details of which pins are for power and which are for comms. It's very quick and easy to get set up. So when it comes to ISA 500, that's the hardware. There's a number of different configurations, as you've seen. We also provide the CView software. So CView provides the ability to show all the outputs from the ISA 500 in real time. So you get your distance reading, your heading pitch, roll. We also integrate a turns counter, so it can sense the number of rotations that the ISA 500 has completed. I take this ISA 500 in the tank and just rotate it a little bit there. You can see the turns counter start to count up. And if I rotate it the other way, it counts back down again. So that can be useful for certain applications. If you're doing asset deployment and you want to monitor turns, twists in your umbilical, it's a good way to monitor that. So I mentioned the ISA 500 outputs range. So it does a measurement, long distance, high accuracy. It can also output energy and correlation values for each reading it takes. On screen, we show that as a color bar chart. So you can see that bar chart moving slightly as the altimeter pings. The yellow proportion of that bar chart is the energy that's been received back to the ISA 500 from the energy it's sent out into the water. And the green proportion of that is how much of that energy correlates really nicely. So how much of it is a nice clean sine wave coming back, and how much of it has distortion on it. So this can be used or thought of as a trust factor for the distance reading. If you get a distance reading like this, and you've got a lot of energy coming back, so quite a long yellow bar, and most of it is green, there's a high probability that that's a very good reading. It's a really nice clean signal coming back. The ISA 500 is certain and confident that the reading is correct. If you get a reading back where the yellow bar is very short, it would indicate only a small amount of energy has come back. Or if you get a reading back where the green bar is quite short, it suggests a very noisy reading has come back. And if you get one where it's low energy and low correlation, it suggests it's a bad reading, one that should have a low trust factor applied to it. So it gives you a little bit more knowledge than just pure distance reading. And then on screen here, we've just got a plot of each distance over time. So if we move the ISA 500 up in the water, you can see that change on the graph. Move it down again, you can see it graphed like that. It just tracks the readings over time. Also in CView, we provide you with a multi-echo output. So you can click on this little multi-echo button here and pull up a separate graph. And this graph here will show you every echo that the ISA 500 hears coming back across the range. So it sends a single ping out into the water and it listens to what comes back. So a lot of the time, if you're in open water, you'll send a ping out into the water, it'll travel, hit the seabed, and come back again. You just get one single return. If, on the other hand, you're operating in a small test tank like we are today, it sends one ping out, and that ping then bounces, hits the base of the tank, bounces back, hits the top of the water, bounces back to the base again, and it sits there bouncing back and forth. And for that reason, the ISA 500 ends up seeing a whole series of echoes going back. So that's the basic CView software. You can also set the CView up to log data, just save it to a CSV file, or output the data to a COM port for feeding into a third-party package. Or if you don't want to use CView at all, you can use CView just to configure the ISA 500, output the ASCII data that you require. So to give you a little example, the ISA 500 is fully software configurable. There's no dip switches, there's nothing inside the unit to physically adjust. Everything is done in software. So when you first go into the settings, you've got the acoustics setup page. And from here, you can set your frequency. So you can run it anywhere from 400 to 600 kilohertz. It's fairly consistent performance across that band. It's quite a wide bandwidth ISA 500 altimeter. 500 kilohertz is the default that we set it to, but you can move it away from there. So if you're running it alongside another acoustic system, maybe a sonar system that's in a similar kind of frequency range, you can move the altimeter just out of that frequency range to avoid any interference. You can also set your speed of sound. So if you're working in freshwater or saltwater, or if you're working in another medium, such as a hydrocarbon, you can adjust the speed of sound to ensure that your readings are all accurate. You can adjust your pulse amplitude anywhere from 1 to 100%. You'll just adjust the volume, the amount of energy that the altimeter puts into the water. And you can also adjust your pulse length. By default, we have the ISA 500 set to a pulse length of 200 microseconds. And this works really well from a range of about 30 centimeters up to 120 meters. But in certain situations, maybe if you want to get really close range measurements from the ISA 500 down to about 10 centimeters away from the transducer, you can drop the pulse length down just to allow it to get a little bit closer to the target you're measuring. You can also gate the responses, so you can set your minimum range and maximum range. So if there's a set distance that you're interested in, you can configure it there. We also have tilt correction. So if you've got an ISA 500 with integrated AHRS providing heading, pitch, and roll, you can turn on tilt correction. And what that will do is automatically correct for slant ranges. So if you've got the altimeter on your underwater vehicle, and the vehicle is pitching and rolling, as the altimeter is sending out pings, it's actually taking slant range measurements. So it's not actually giving you true altitude, it's just giving you the slant range measurement. If you turn on tilt correction, it'll take into account the angle that the ISA 500 is sitting at, and it'll automatically work out what is the actual altitude. So you can have the altimeter, you can move it like this in the water, and it'll sit there and give you a very constant altitude output, which is great if you've got an auto altitude system on your vehicle. You want a really stable input to that. The last item you can change on the acoustic side is your detection mode. So on the detection mode, we have several options. The two main ones being first echo and strongest echo. So first echo works by transmitting a pulse of sound, and as soon as it hears any return coming back, it'll use that to trigger on and give you a range reading. That works really well in enclosed spaces, such as tanks that we have here today. The other option is strongest echo. So if you select strongest echo, the ISA 500 will send out an acoustic pulse. It'll listen to every single echo that comes back again, and it will select one of the highest amplitudes and use that to lock on and give you a range measurement. This is really useful for open water. If you're working in the sea or in a lake, then this is ideal. Using the strongest echo method, we'll send out the ping. It may get like smaller pings of fish, really large echo back from the seabed. It'll then ignore all the smaller returns, focus on the seabed, and give you that range reading. So using the strongest echo detection method ensures great stability when you're in open water. So that's about everything on the acoustic side. You can also set up an analog output. So if you want a scaled voltage to be output from the ISA 500 relative to the range it's measured, you can set that up there. You can set up multi-echo output. So if you want the ISA 500 to output more than just a single reading, you want it to output every single echo that hears coming back, or the first 10 echoes or the first 5 echoes, you can configure that here. The connection, you can configure it for 232, 485, or 485 terminated, and you can set the baud rate. And we get down to the output. These are the standard ASCII output strings that the ISA 500 altimeter has saved in its firmware. These are all detailed in the manual if you want a breakdown of exactly what's in each string. So we've got all the kind of common industry standard strings there. So it means that if you're replacing another altimeter in your vehicle, you can quickly set the ISA 500 up to emulate its output. So there's no engineering effort on your side. It's just a plug-and-play solution. You can also set up all the AHRS settings. So you can set up the orientation of the ISA 500 so it knows where to take the heading, pitch, and roll readings relative to. You can also put any offsets in there. You've also got the ability to set up the output for the AHRS side of things as well. So if you want to output an ASCII string with heading, pitch, and roll, it's really quick and easy to set up. So that's a quick run through of the ISA 500 family of altimeters, the CView software, which supports the ISA 500 sensor itself. If you want to learn more about the ISA 500, then our website has a ISA 500 page under the product section, which talks you through all the technical capabilities. We also have several articles under the news and features section of our website, which go through all the technical side of the ISA 500 in more detail than I've gone through here today. It's worth a look. And if you have any other questions at any time, feel free to drop us an email at support@impactsubsea.co.uk or give us a call. That's all for this week. Thank you.